Good morning, everybody. If you haven't taken seen the handouts up front, there's 2 handouts for today, 2 practice quizzes for next week. How's everybody doing? Thumbs up? How's the semester going so far? Is it, it's usually this time of the semester's kind of a light time. It's not yet midterm time, not yet any big projects. Is that how everybody feels right now? Is this like
this is the busiest time.
Busiest time?
Busiest
you've ever been in your life?
Yeah. Personally.
Like because of classes, because of this class, because of other things?
I would say everything. I would say this class is like a good busy. Like it's a fun busy.
Okay.
This is not dreadful.
Not dreadful, I'll take it.
No, I mean, the
Yeah.
exact opposite of dreadful. Not even close.
What about what are the kinds of things like outside of class that are keeping people busy? Just having fun.
Copies.
The fun presidential elections for first year is coming up, and that is that's me. That's keeping me busy.
When's the election happening?
Thursday the 27th. Wait, Thursday next week.
Okay.
The 23rd is our lovely speeches on Green Beach, I believe. And you can also, if you haven't linked my page or liked my webpage, it's about my platform. You can see my policies. It's on the policy page. And then a little bit about me is on the About Me page. So go
like
check that out.
Combining classwork with other things.
Indeed. I also have an Instagram, Natalie4FYC. So go check it out and tell your friends. Especially if they're freshmen. Or if not. Either way. Any support, I'll take.
Stuff the ballot box.
Yep.
Wait 1 more minute before we get started here. See, anything else fun we can talk about? It's just a quick reminder about you have the those required reading / viewings to do. Now is a good time of the semester to do those sorts of things. When even if you are busy right now, you'll probably be a lot more busy come finals week, and you don't want to have other things like that stressing you out. Yeah. Yeah, so the required reading and viewing is you have the option of either reading the Harry Potter fan fiction written by that AI security researcher. So if you like reading things, do that. Or if you like watching things, then there's a couple of movies / the Mr. Robot TV show to watch. Okay, it's 11:10, official class get started time. Again, if you haven't taken, there's 2 practice quizzes up here. If you don't have a copy, you should come get one. We'll be going over those in class today. Before we do that though, let's just talk a little bit about grades. So at this point, everything you've done so far is graded. And so on the first 2 labs, everybody got full credits. If you submitted it, you got full credits. There was I think on the very first lab, there was a little bit of confusion because there was the multiple different sections being created. And if you had submitted the lab to the old section on Sakai, the old Sakai classroom instead of a new one, then that was okay. But in the future, please make sure to submit to the new Sakai section, the one that's not like section specific, but for both sections. That way I will actually find it. Most people did really well on the homework 0, a lot of 10 out of 10s. The main way that people are missing points is that there's still a handful of web pages that have not been submitted, and so there'll be late penalties applied to that. As a reminder, the late penalty in this class is 20% per day late. So you have 5 days before it goes down to a 0. You should, it's very common in this class, one of the things that people do on accident is you spend a lot of time working on your web page and it's online and it's really cool, and then you just forget to actually go to Sakai to submit it. So make sure that you're just not in that situation and go check your grade on Sakai. For the quiz, so last week's quiz, the average was a 7 out of 10. And if you feel like you were on the did not get the grade that you wanted to, you shouldn't feel like worried about your grade at this point in this class. That quiz is very, very small percentage of your total grade, and there will be lots of extra credits and future homeworks that you can do to get points. The extra credit on the homework 0 was relatively small and relatively hard to do compared to the extra credits that will be coming up in the future. One of my, I guess, guiding principles as a teacher is that if you just have like a bad week or a bad day or something, I don't want you to be like penalized for that. That really, as long as at the end of the course you've demonstrated the knowledge, then you will get a grade corresponding to the knowledge you have at the end of the course. So at any point, if you just have a bad week or a bad series of weeks, it's always possible to come back. You'll just have to put in the work to come back and demonstrate that knowledge. In general, if your goal is to get an A in this class or an A-, anything above the 90% mark, then the 7 out of 10 on quizzes is sort of like the lowest that you want to be. So that is would be like a C- just on that quiz, but because there's the labs and the homeworks that also have the additional weight, a 7 out of 10 would be boosted up to just about the 90% mark. Assuming you do get good scores on the labs and the homeworks. And again, on the labs and the homeworks, so we'll talk about the Python labs, how they'll work today towards the end of class, but you'll know exactly what your grade is when you submit it, so you can just keep working on it until you get the perfect score, or until you get the score that you want. Last thing about the quiz, there were a handful of people no-showing for the quiz, and so you get a 0 out of 10 if you don't show up. Again, unless you contact me beforehand. So if for whatever reason you're sick or quarantined or something like that, just make sure to contact me beforehand so you don't get the 0 on the quiz and it just doesn't count towards your grade. But if you contacted me beforehand, then you should not get a 0, it'll just be waived. So let's jump down to this point real quick. If there is a mistake in your grade, this is one of the things that email me about. Don't post an issue to GitHub, and we'll get that taken care of. This is the kind of thing right here, like if I accidentally gave you a 0 out of 10 on a quiz or something, when you had emailed me, I just lost it somehow. We should get that fixed earlier rather than later, because it'll be a lot harder to fix later than fixing right now when everything's fresh in our minds. Okay, and last thing about grades is that, so with the lab and the homework and the quiz, everything together, the current average is an 89. Any questions about anything grade-wise in this class? Either past grades or what to expect in the future? Or,
how often are we going to be having the homework assignments?
Good question. How often are the homework assignments? So there's 6 of these larger projects. So you have weekly labs plus 6 of these projects. You've already done 1, so there's only 5 left. There's, yeah, so 15 weeks in the semester, 5 projects left, so every 2 to 3 weeks is what to expect. And on the GitHub page, there is a sort of like a proposed timeline when I think the projects are going to be due, so that you can just keep that in mind. And my promise is that I will not have the due date be any earlier than those proposed dates, but I might give you extra time and move the due dates later. Any other questions about grades? Okay, then today we're going to talk more Python, and in particular, what are called control structures in Python. So we'll see the if statement, the while statement, and the for statement. And we're going to go over these concepts by going over the practice quiz. So again, up front, there's 2 practice quizzes. If you don't have copies, come up and get them. Today in class, we're going to go through practice quiz version 1. I'm also giving you the practice quiz version 2 so that you just have something that you can try completely blank slate on your own and see how well you do. If you, again, thinking back on your grade for the first quiz, if you're happy with it, the same sort of study techniques are probably going to work well on this quiz. If you're not happy with your previous grade, then you need to change something up for the second one. Is there a question?
Oh yeah, is the Friday review?
Yeah, so there's not going to be a Friday review of the quiz. We're going to do it just in class today. Yeah. So the yeah, so there should be 2 separate versions of the quiz, version 1 and version 2. We're going to go over version 1 in class. You have version 2 to practice with at home. I'm giving you 2 different practice quizzes this week because it's a particularly important, these concepts are particularly important, and everything from here on out, you're going to have essentially perfect knowledge of what's going on in this quiz. So yeah, pay extra attention to this quiz. Okay, so let's actually go take a look at the quiz. And so problems 1 and problems 2 sort of are reviewing the concepts that we covered last time in class. The purpose of these concepts, or the purpose of these 2 problems, is to just know what are the different math operators in Python, and then the second one is also knowing order of operations. So for any of these problems, you can always check the answer yourself, get the answer yourself by just typing this into Python. So I'm going to copy and paste this problem right here onto my clipboard, and then come over here to VS Code and paste it right here. So this is just the very first problem on the quiz, and I'm going to press the triangle button to run it. And so we can see that the answer here is z equals 5. So when you're actually doing this, when you're working through it, you want to go step by step, actually try to do it by hand, test your understanding, and then to know if you got the right answer or not, just type it into Python and check. All of these operations are things on the Python cheat sheet. So right here in the, down here, bottom left corner math, this is where the first 2 problems are going to come from, is these math operations. So last time we talked about the sort of normal math operations, plus minus, the star is multiplication, the slash is division. Today we'll talk about this double slash, which is called integer division, and this percent sign, which gives you the remainder. And then last time we also talked about the star for exponentiation. With the remainder operator, let's see, these slash and these percent operators are, they're definitely going to be on the quiz because these are things that students always confuse, and so it's going to be on the quiz, guaranteed. What this slash does what / does is it does division and then discards whatever the decimal part is after the division. So if I do 4//3 like this and just print that out, triangle button, print it out, we get the answer 1 because 3 goes into 4, like 1.333333 times, so 1 time. Just take the integer part of the division.
Does it round it off or just take the?
Good question. The question is, does it round or, and the answer is it does not round. It just, even if it's like 1.99999, it'll still give you just 1. So here, 5 divided by 3, if we were rounding, we would get 2, but here we'll see we're not rounding, and so we still get 1.
So 2 divided by 3 would be 0.
Exactly, and so 2 divided by 3, 0. So this is something that is a little bit confusing. This is a common place where students make mistakes, is that when you have the thing on the left being smaller than the thing on the right, it should just be 0, but sometimes students decide to do it backwards and do 3 divided by 2 and put 1, thinking it should be 1.5. But it's okay to get 0 from these integer division things, and yeah, so in this case it's 0. Here's a little hint for the quiz. On the quiz, we're only going to have integer math problems because, like we talked about before, any of the floating point math is represented in a really complicated way internally in the computer, and it's not all intuitive that you do something like 0.1 plus 0.1 plus 0.1 not equal to 0.3. And so you're not expected to understand the details of the floating point math, the math with decimals, only the math with integers. So if you think you're getting a decimal, for whatever reason, then you've definitely made a mistake. So that's the double slash. The parenthesis, also called the modulus operator, or informally the remainder operator, gives you the remainder. So if we did, let's do our 4, remainder 3, run that, gives me 1. 5, remainder 3, run that, gives me 2. 6, remainder 3, run that, gives me 0. Another really common mistakes that students make is that if we have 2 remainder 3 like this, you'll think that, okay, rather than doing 2 remainder 3, you'll do 3 remainder 2 and put the answer 1. But the answer is actually 2 because when you do 2 divided by 3, you get 0 with 2 as a remainder. So run that and we get 2. So with this double slash and with this parenthesis, or percent sign, very common for students to make mistakes when the left number is less than the right number. So pay extra attention in those situations. Eddie.
Just question. 2 divided by 3 means that the 3's 3 times by 0. No, remainder. So it means that 3, it's meaning that 3 times 0 plus 2, which the 2 is the remainder.
Exactly.
Gotcha.
Let's see. So this first problem is intended to hopefully be easy. All it's asking you to do is go step by step. Do you know what the different math symbols are? The second problem is a little bit more complicated. And here, not only do you have to know the math symbols, but you have to know their order of operations. And the order of operations in Python is the same as in traditional math. So the first thing that always happens is parentheses. In this case, there's no parentheses. So we move on to exponentiation. So it's always, oops. It's always first parentheses, then the exponentiation. And so in this case, what we have down here, what we do first is this exponentiation right here. It's like there's parentheses around this right here. And so 2 raised to the 2 power is 4. The numbers that I give you are always going to be just like really simple numbers like 1, 2, and 3. So you should be able to work it out in your head just what these things are. So 2 squared gives us 4. Then the next thing is the multiplication, division, integer division, and the percent sign all have what we'd call the same precedence. So these all go together. And if they happen in the same spot, you work left to right. So here, we have a multiplication. So let's go ahead and do the multiplication. 2 times 4 gives us 8. So this whole thing right here would be 8. And then on the right-hand side, we have this 3 times 4 happens before the 4% 2, just because it is to the left-hand side. You always work left to right. We're not doing the plus, though, because plus comes after all of these things. So 3 times 4 is 12. And then 12% 2 is 0. And then the last thing is the plus and the minus. And so we have the thing on the left, 8 plus 0. So the whole answer would be 8. And we could check this again just by typing this into Python, and it would print out the number 8 for us. Any questions about order of operations? Yes. Sure. So the question's about the percent, and what percent does is, so if we have, let's do different numbers. Let's try 12% 5. What percent does is it takes the thing on the left, divides it by the thing on the right using that sort of like integer division. So 5 goes into 12 2 times, and then we have a remainder of 2. So if we ran this, we would get the number 2 because the remainder here is 2. If we change this to 4, 5 goes into 14 2 times with a remainder of 4. Run that, 4. Did that answer the question? Okay. Miles.
So the double slash is it just removes the remainder in the percentage only.
Exactly. So the double slash removes the remainder. The percentage only leaves the remainder. So we have this general principle of that if we had a number like x, x is always going to be equal to x divided by something times that something plus x% something. So if that's confusing, if that's not helpful, just ignore it. You don't need to know that. But if that is helpful, then there it is. That you can always break up a number into 2 parts using the slash slash and the percent. Is there another question over here, Natalie?
And what did you say about if let's say it was flipped, it was 5%, 14? What?
Yeah, so the very common mistake that students make is that when the number on the left is less than the number on the right, well, what students do is you just like flip, okay, it doesn't make sense in my brain, so 5 divided by 14 doesn't make sense, so I'm doing 14 divided by 5 instead. And so you don't do that. In this case, yeah, the answer here is just 5, because 14 goes into 5 0 times with a remainder of 5. So this is a big source of students missing points on quizzes, but even more importantly, when you're writing programs, they won't do the right thing if you have that misconception. And so you'll be staring at your code for hours, not knowing what's going on, and be very frustrated. So yeah, just if the thing on the left is less than the thing on the right, just make sure you're paying extra attention.
And wouldn't it always be, you're always getting the
Exactly. With the percent operation, when the thing on the left is smaller than the thing on the right, the answer is always just the thing on the left. Okay, so those are the first 2 problems. And those are essentially a review from last time. Problem 3, we're going to start talking about new concepts that we didn't talk about last time, but it's also a really straightforward sort of concept, I think. So I think people will generally do well on problem 3. Here, what I've done is there's some small amount of math at the top, but then there's this new statement of an if statement or an else statement. And so let's work through, again, in Python, you always start at the top and go down, and then we'll talk about these when we get to them. So this first part here, x equals 4% 5, what's the answer? Somebody shout it out. Answer is 4. And then y equals 4 slash slash 5, what's the answer? 0, good job. And so now in this if statement, we call this part right here the condition of the if statement, and we do what's called evaluating this condition. We plug in our numbers 4 and 0 here, and we check to see whether this is a true statement or a false statement. So x equals 1, x is not equal to 1, so this right here is going to be false. That's false. And similarly over here, y equals 1, that is, y is equal to 0, it's not equal to 1, so that is going to be false as well. And this or operator right here, it'll be true if either the thing on the left or the right is true. Since they're both false, it's going to be false as well. So this whole thing is going to be false. The entire condition is false. When we have a if statement with a false condition, we do not execute what's inside right here. So we do not execute this. Instead, we do what's in the else spot, and we execute this right here. So this is what we do because the condition was false, and so we have that result equals 1. That will be the output. So correct answer here is to say result equals 1.
We have to write the whole thing. Result.
Question is, do you have to write the result equals? So you'll get full credit on the quiz as long as you have the right number here, but you should be in the habit, get yourself into the habit of putting out being exact as literal as you can. Eddie.
Just one quick question. So when do we use double equal?
Good question. The question is, up here we have this double equals, and what exactly is the difference between double equals and when do we use that versus single equals? In Python, single equals is called the assignment operator. And I'll abbreviate operator with just op. It's a common abbreviation. And every time you see a single equals by itself, it means the thing on the left-hand side must be a variable, and the thing on the right-hand side, we're putting it into the variable. An assignment operation is never going to be inside of an if statement. Never within an if statement. And I'll abbreviate statement as STMT. This double equals right here is just called the equality operator. Double equals is the equality operator, so EQ period, op period. And this is what actually checks, is the thing on the left equal to the thing on the right? Up here, I've put a variable on the left and a number on the right, but there's nothing that obligates me to do that. I could have said 1 double equals X. That's okay, perfectly okay. I could have said something like 1 equals 2. That's perfectly okay. But it's never okay to have something like 1 equals X. That's never okay, because the thing on the left of an assignment operator must always be a variable, but that's not the case with this equality operator. The rule of thumb is that if it's inside of the condition of an if statement, use the double equals. If it's outside of the condition of an if statement, use a single equals. On the quizzes, I'm never going to give you like malformatted Python that is broken in some way. So like it'll never have X equals equals up here on this line, and it'll never have X single equals down here in this line. It'll always be valid Python code on a quiz. The main way that students make mistakes with the if statement questions is making mistakes with actually evaluating what's inside of the condition up here. So you should just double check that you understand all of these, what these condition operators mean and what or and mean as well. On your Python cheat sheet, let's come back over here. This Boolean logic, you'll need to make sure that you understand everything inside of this Boolean logic. So you need all of these operators up here, and the and or the or and the not down here. And then also just true and false mean just true and false. Yes.
So just to clarify, the double equal isn't like necessarily stating anything, it's just asking the computer like, is this true or false?
Exactly. That's a good way of thinking about it, that the double equals is like a question. You're asking the computer, and the single equals is like a command, like make this equal. Not double equals is question, is this equal? Single equals is make this equal. Okay. So the main way that students mess up here is on the conditions, evaluating the conditions, but usually students do pretty well on this part. Problem 4 is the first part where things get particularly confusing for students. And that's that inside of the if condition right here, so again, the thing that comes after the if statement is called the condition. So here, this is the condition. And here we have our condition is a string. Whereas up above, our condition was like true or false. And remember, true or false in computer science is a Boolean. So up here, this is a Boolean. It was true or false. Down here, our condition is a string, not a Boolean. And in Python, there's this concept of truthiness. And if you're Colbert watchers, you might be familiar with his version of truthiness. But Python is the original inventor of truthiness. It invented it before Stephen Colbert did. I have no idea if he stole it from here or not, but this is the original truthiness. And this, every type has what's called a truthy and a non-truthy value. The non-truthy value is somehow supposed to be like the simplest version of that type. So here, an individual string like this is, that's kind of like the same as false. And if we had something inside of the string, doesn't matter what it is, so something like test, that's kind of like the same as true. For numbers, 0 is sort of the simplest number. So 0 is kind of like the same thing as false. And any other number like 3.75 is kind of like true. At this point, we've only talked about numbers and strings, so those are the only like truthy values that you need to be aware of. But you should make sure that you played around in Python, just do some experiments. Again, we're computer scientists. We run experiments to learn how the computer works. Just copy and paste this into Python and try out some different things right here that are not just greater than, or equals, but actual like numbers or string values.
So because there's nothing in this single quote, it's
Yeah, so here there's nothing in the single quote, so the truthiness value of this is false. So we don't do the true part here, we go down to the else, the false part down here, and we set result equal to 1. And so we say print result equals, and then if get a 1. So result equals 1 is the answer here. Yes?
So what if in the single quote, if there's something, let's say.
If there's anything at all, space, doesn't matter, anything different than this is going to be true.
Even though it's just a space.
Even though it's just a space. Okay, so this sort of trips up students because it's just kind of like a hard thing to remember. It's sort of like an edge case or an irregular thing about Python. It'll come up a lot later in this class though, so make sure that you have a good, I guess there's not too many things right here just to memorize. You can just write them out on your cheat sheet and that should be good for the quiz. Problem number 5 though is where like the weird grammatical rules about Python start coming in, and we have to really like sit down and think. And the reason for that is that we're introducing this while statement right here. So previously it was if statements. Now we're talking about while statements. And in order to talk about this piece of code, we're going to go to the pythontutor.com website. So come over to, where do I have my Firefox? Let's just open up a new Firefox. pythontutor.com is the website. And then there's lots of different buttons that you can click on this first thing that you go to, but you want to click on this Start Visualizing Your Code Now button right here. And when you do that, it gives you this little text box that you can type in Python code into. And so I'm just going to come over here and let's copy and paste this Python code again. So copy to clipboard, come back over here and right click paste. One of the things that you'll notice, which is a little bit frustrating, is that at least on my computer, the white space when I paste in here is not kept. So you have to be careful when you're pasting into Python Tutor to make sure that the white space is what it's supposed to be. So on the quiz, line 4 right here, this total equals, that's indented 2, 3, 4, so that it is inside of the while statement right here. And this is required to have it work correctly. If you don't do this indentation, then things will not work correctly. So 1, 2, let's indent it like this. And then you come down here to the Visualize Execution button. Another thing that's frustrating about copying and pasting into here is that the quotation marks often get warped with things that look like quotation marks but aren't actually quotation marks. So you can see how this quotation mark right here looks a little bit different than this one right here. So you might have to just delete it and then re-add it back in order to get an actual quotation mark. Now come back and visualize execution. And this is what we go. This is what we get. So here, the I equals, we're starting off at this I equals 0 line, and we run one step at a time, one line at a time. So I'll press the next button to make Python just execute the line that the red arrow is currently at. Over here on the right-hand side, this thing called global frame, this is a list of all the variables that you currently have access to and what their values are. So here we have I equals 0, and then and that's the only thing that we have so far because we've only executed this first line. I press next again, and we do line 2 right here, and now you can see total equals 0 has appeared right here. Line 3 is where the while statement happens. A while statement is like an if statement in that it checks to see, is this condition right here true, or is it truthy? The thing to the right of the while statement is called the condition of the while statement. And if it is true, or if it is truthy, then we go inside of the while statement like this. So now we're on line 4, and inside of the while statement, because we're in an indented block right now. I'll go ahead and press next again to make total equals total plus I. And we executed that line, total equals total plus I, and then we come back up to the while statement. The difference between a while statement and an if statement is that an if statement, once you execute the body of the if statement, once you execute this, the content in this block, you go on to the next statement after the if statement. And a while statement, you don't go on to the next thing, you go back to the while statement. So you keep doing this while this condition is true. In this case, actually, it looks like I have a typo in the quiz. I apologize for that. But this condition is always going to be true because the I value never changes. So I'm going to edit this real quick. I meant to also say I equals I plus 1 right down here. Oops. And we'll visualize that now. And now, starting at the top, we have I equals 0. Then total equals 0 again. Now our condition y, while I is less than 5, go inside. We do the total equals total plus I. Well, total equals 0, I equals 0. So we evaluate 0 plus 0 is 0. Stick that back into total, so total stays at a value of 0. Down here on line 5, we have I equals I plus 1. I equals 0. 0 plus 1 is 1. So this right-hand side evaluates to 1. We stick that 1 inside of the I. And so you can see that the value of I over here changed from 0 to 1. In Python Tutor, you can go backwards and forwards. So I'll go backwards to where I was before. Notice that I is equal to 0 on line 5 right now. I press next to go forwards, and notice that I changed to a value of 1, because that's what it evaluated to right here. Now we have that 1 is still less than 5, so we go through. Total equals total plus I. So now we have total is 0, I is 1. And so we'll get 0 plus 1 is 1, and stick that into total like this. Now we have I equals I plus 1, I is 1. So substitute 1 over here. We get 1 plus 1 is 2, I equals 2. And press next, I is equal to 2. 2 is still less than 5, so we'll go inside of the block again. We'll get total equals total plus I. Total here now is equal to 1. I is equal to 2, so 1 plus 2 is 3. So our new value of total is going to be 3, like that. I equals I plus 1. I is currently 2, plus 1 is 3. And we go up here. And we'll keep doing this. Each time I will get bigger and bigger until eventually I is equal to 5. Now we have I is less than 5. Well, I is equal to 5, and 5 is not less than 5. 5 would be less than or equal to 5, but it's not less than 5. So 5 less than 5 is going to evaluate to false, and we're not going to go inside of here and do this condition. Press the next button, and we'll jump down here to line 6. And then one more time, execute line 6, printing out the value of total. And up here in the top right is the actual output of our program. So total equals 10 is what the fixed version of this code would be if you add this I equals I plus 1 line to the quiz.
This is a loop, right?
Question is this a loop? And yes, the while statement is also sometimes called a while loop. Loop is just anytime you're doing the same block of code over and over again. And we'd say we're looping over this code right here because it's inside the while loop.
So, but while the value, total value is 10, isn't the value of I 5? It shouldn't be less than 5.
The value of I is 5. Let's see, let's back up to right here. The value of I is 4 at this point. 4 plus 1 is 5. So we get to 5 right here. And now we have 5 is less than 5. So that evaluates to false. Yes, Sophie.
Are you ever gonna write it so like the I equals I plus 1 or whatever is gonna be outside the loop? Or is it always gonna be in the loop?
This is a good question. So the question is on line 5 right here, what if this I equals I plus 1 was outside of the loop instead of inside of the loop? So let's go try that out. Let's do an experiment. And we'll put it right here like this so it's outside of the loop and see what happens. Visualize this execution. And let's step through this. And you can see that on line 4 right here, we execute this total equals total plus I. But then we come back up here to line 3, and we do not come down here to line 5. Line 5 is indented to the left, so it is outside of the while loop block. It is not something that we do as part of the loop. And so we'll never actually add anything to I right here. Technically, what we have right here is called an infinite loop because this I value is always going to be less than 5. We're never modifying the I value anywhere inside of the while loop. So that means if this condition is ever true, it's always going to be true forever. And so this code is going to continue to run and run and run and never stop. So if you see this red error message down here, it's saying that, that your code never stops, and that's why there's an error message right here. On the quiz for Monday, I guarantee that you'll have code that stops, and it's not going to go on forever.
So the output is something.
So the question is, in this case, is the output nothing? And the technical answer is the output is not nothing, but it's also not something. That there is something different than nothing and something, and that's what's going on here. We don't need to know about the technical things. At this point, you just know that I'm not going to give you an infinite loop. It's going. If you think that it's not stopping, then you're making a mistake. The code that I gave you originally, though, on this version 1 quiz did not have this line 5 inside of it. And so it was a typo. It was an infinite loop, but you're not going to have something like that on the actual quiz. So just make sure that you make a note that it's supposed to have this I equals I plus 1 inside the while loop. Good questions. Any other questions so far?
So if it does have line 5, it's 10. If it doesn't, it's kind of an infinite loop.
If it doesn't have line 5, it's an infinite loop, and you don't need to worry about that case yet. Just know that that's something that can happen in a while loop, but it's not going to be on the quiz. Okay, so this pattern of loops where we have this sort of I variable, it's kind of like counting a number and it's changing by the same amount every time. This is a really common pattern in programming. And it's so common that we've invented another type of loop called the for loop, which does this for us automatically. And the remainder of your questions on the quiz go over this for loop. So starting at problem 6, we have an example of a for loop. For loops at first look a little bit more complicated than while loops because there's a little bit more just writing going on. But they're actually much, much simpler and much, much easier to work with. And 99% of the time, you'll want to be using for loops instead of while loops when you have the option. Here, this variable right here, this defines a new variable. This right here is a new variable. And this over here, this range, specifies the values that this I variable will take on. Specifies the values of I. And so when we have range of some number, so say range of the number 5, that's going to give us all of the values between 0, greater than or equal to 0, and less than, strictly less than 5. So something like 0, 1, 2, 3, 4. I will be equal to all of these values. And it'll first start from the left, execute the block with I equals 0, then with I equals 1, then I equals 2, then I equals 3, then I equals 4. And so before we talk about exactly this problem right here, I'm going to go back over to our code that we had up here and rewrite this using, so I'll comment this part out and rewrite this using a for loop. So we have something like total equals 0 for I in range 5. Total equals total plus 1, and print total equals, comma, total like this. So the actual for statement itself is a little bit more complicated than the actual while statement, but notice that the total number of lines is smaller. Up here we had 6 lines, down here we have 4 lines. And because of that, it'll be a lot easier to work with. I'm going to do this visualize execution again, and we'll step through. Each time, let me back up a little bit here. Okay, so we're on line 10 right now. Execute line 10, we specify total equals 0. Then on line 11, for I in range 5, when we do that the first time, it creates this variable I. Notice that beforehand in this global frame box right here, there is no variable I. Then when I first execute this line, we get this variable I, and it starts off with 0 because 0 is the first thing that this range contains. Then I do this total equals total plus 1. And sorry, in order to make this the same as it was up there, that should be total equals total plus I. Let's do that real quick. Total equals total plus I instead of total equals total plus 1. So that the content of this block is the same as the content of this block up here. Redo this, back on this step, total equals total plus I equals 0, total equals 0. So run that, total still stays as 0. Now you go back to line 11 for I in range 5, and the next value after 0 in the range is 1, so I takes the value of 1 when we execute that line. On line 12, now we have total equals 0 plus 1, so we get 1. Back up here, I will be 2 next. Total equals 1 plus 2, so 3, and keep running that. And we get this ending with total equals 10 and I equals 4, just like we did up here. And press next, printing out total equals 10. So the quick summary before I take questions is that in the for loop, you're always creating a new variable right here. It's traditional to use the letter I, so that's what I'll be using. And then you always have this in keyword. It's always for variable in. And then the thing on the right, technically can be, there's a lot of options here, but for now, where it's always going to be this range, and then there'll be a number inside of it. And we'll go from 0 up to that number, not including that number. So I less than 5, starting at 0 is the same as range 5, like this. Questions? Natalie?
Let's say that the problem was as it was, where it's like total minus 1. The total would be -5, but it like the I problem would be would stop at 4, right?
Yes, good question. Let's go ahead. So the question is on the actual quiz problem. So what I wrote up here was not the quiz problem. What I wrote up here is translating the previous quiz problem from while loop format into for loop format. And we'll comment out both of these. And now let's write the actual, the quiz problems. I think it was total equals 0 for I in range 5. Total equals total minus 1. Print total equals, comma, total. Is that, did I get that correct?
Correct.
For the quiz? Now we press visualize execution. Because we have these comments up here, we'll have to press the next button a couple times just to get down to our actual code. And now when we're going inside of here, the I value is going to be 0, 1, 2, 3, 4. So look at the I value up here, ignoring the total for a second, 0, 1, 2, 3, 4. And then the total, back up now, the total is now being always subtracted by 1, minus 1. Instead of being adjusted by I, it's being adjusted by 1. So, and it's going down instead of up. So -1, and then it's always the same number, always a -1 that's being subtracted over here. So we get to -5. I think the particular question though, what it was about, and this is another like common mistakes that students make, and so you should pay close attention right now. This I value ends at 4. But the total ends at 5 because we also have to not forget that we do the 0 as well. If I change this from a negative to a positive like this, visualize this execution, press the last button to run everything, we get total equals 5, but I equals 4. I went from 0, 1, 2, 3, 4. So it stops at 4. You're tempted to think that it happened 4 times, but you don't forget that it happened for the 0 time as well. So range, the reason why we put a 5 in here, even though it stops at 4, is because we're counting the 0, and so it actually happens 5 times. Did that answer your question, Natalie?
Yeah, that's great.
Good. Any other questions so far? Okay, on your quiz, you're gonna have just one question involving the while loops, and then everything else is going to involve the for loops. And they're just going to sort of build on just these more complicated variations of the for loops. The first thing that can make things more complicated is that this range function actually has different ways that we can call it. And this is all inside of your cheat sheet again. So let's come up here and iterative loop statements down here. Everything that we're talking about right now is in this iterative loop statements right here. And everything that we just talked about is in this iterative loop statements. What we're talking about next is in this integer sequences box. So you can see that there's different forms that this range operator can take. It can take one option, it can take 2 arguments, or it can take 3 arguments. And it has some examples right here to help you understand what's the difference between each of these. So whenever there's just one argument, then we always start at 0 and go up to, but not including that argument. So 0, 1, 2, 3, 4 for range of 5. When there's 2 arguments, we start at the number on the left and we go up to, but not including the number on the right. So 3, 4, 5, 6, 7, range 3, 8. When there's 3 arguments, this third argument is called the step. And so we increase by the amount on the step to the right. So instead of increasing by 1 each time, when we do 2, 12, 3, we increase by 3 each time. So 2, then 5, then 8, then 11. Notice that if we kept going, we'd go from 11 to 14. 14 is greater than or equal to 12, so we do not include the 14. It's also possible for the range, you don't have to just count from positive numbers from low to high. You can also go high to low with a negative step size. So here, starting at 20, going down to 5 with minus 5 at a time. So 20, then 15, 20 minus 5 is 15, 15 minus 5 is 10. If we did 10 minus 5 again, we would get down to 5, but 5 is equal to 5, so we never include things that are equal to this end number over here. So this, you should definitely be relying on this box during the quiz on Monday and make sure that you understand what each of these things actually mean. Are there any questions about the range function? Is that a question?
So basically, you never get to the number at the end. Even if it's only number there, you start at 0 and you never get to that.
Exactly. You will never get to this number at the end, no matter what. No matter what your step size is, no matter what your start thing is, if you have a number at the end, it's guaranteed never to be included in the loop. So this is the first difference about this, this problem. Where did it go? There we go. Number 7, the first difference is that it has 3 different arguments right here. And so I might give you ranges with 3 arguments or with 2 arguments or with 1 argument, and you have to know exactly what it's doing, what the values that I will take on. The second difference is this line right here. We're introducing a new math operator, this percent equals. And every operator, every math operator has a version like this that is the math operator with an equal sign at the end. What this does is it expands into total equals total percent I. So whatever the actual operator is right here, before the equal sign, that is going to be what goes on over here. And this is just a really, really common pattern of doing something equals something plus I or times I or all the different math operators. And so that's why we've created this special syntax so that we don't have to type out this entire thing. So at this point, hopefully you should be able to work through exactly what this is going to do. I'm going to give you just maybe a minute to try to work through it on your own, and then we'll type it into Python Tutor and go through it up here. So take a minute, try to work through what the final answer is going to be, and then we'll walk through it on Python Tutor. Question? Okay. Okay, if you haven't finished, that's okay. But we're gonna just walk through the steps right now. And so I've pasted the problem up here, and we'll do the visualize execution. Takes us over to this step. Press next. So total gets assigned 42, the answer to the life, universe, and everything. And then number 2, for I in range 10, 15, comma 1. So I starts at number 10. When there's 3 numbers, you always start with the leftmost number. And then we do total percent equals I. Do equals, or sorry, go next. So total started at 42, and then we do next, and now total is equal to 2, because 42% I was just 2. Next, I is going to not be 10 anymore. We'll add 1, because 1 is the step over here, and get to 11. And now when we do total percent 11, well, 2% 11 still is 2. So nothing changes. And if we keep pressing this next button, we'll see that so total is always going to be smaller than this I value, and so it's not going to change anymore. When you're working on the quiz, so this is I guess I don't consider this a trick problem, but maybe you might consider this a trick problem because this operator ends up basically being meaningless after the first time that you run it. And if you're ever working on the quiz and you can just like, recognize this pattern that it's not going to change, you don't have to keep manually working through things. The only thing that's important on the quiz is that you end up getting the final results at the end. And as you get more experience working on seeing lots of examples of these things, you'll end up getting a sense that there's lots of times where you don't have to just manually work through step by step on everything, but you can start picking up patterns like that. So if you do see a pattern on the quiz, feel free to take advantage of it and skip ahead to the answer. If you don't, then just go step by step, and that'll never steer you wrong. Question 8?
So, after all these results, did 4, it's also going back like while. Then what is the fundamental difference between while and 4?
So the question is that in a while loop, after we got to the end of the block, we come back up to the beginning and sort of loop. We repeat over and over again. And then a for loop is very, very similar, because when we do a for loop, when we get to the end of the block, end of the contents of the for loop, we come back up to the for loop. And so the question is, what exactly is the difference between a while loop and a for loop? The answer to that is very subtle and borders on philosophical. It's sort of like, what's the difference between a simile and a metaphor? Like, they're almost the same thing, but just very, very slightly different, and only certain people even care about the difference. It turns out that anytime you have a for loop, it's possible to replace it with a while loop that does the exact same thing. The converse statement, though, is not always true. There are some things that you can do with a while loop that you cannot do with a for loop. An example is having an infinite loop that goes on forever. So we saw I made that mistake, that typo at the very beginning, where I had the while loop that goes on forever, and that was bad. That's not what we wanted to have happen. One of the reasons why people prefer for loops over while loops, if you can ever use a for loop, do that, not a while loop, is because you can't have that infinite loop happen. You're always guaranteed that it's going to happen a certain number of times. And just by looking at the range up here, I can tell, okay, 15 minus 10, step size of 1, it's going to happen exactly 5 times. I don't even need to look at the contents of this to know how many times something is going to happen. So if you feel like for loops, while loops, they're kind of the same thing, that's an okay place to be at right now. Just know that if you can use a for loop, use a for loop. Yes. Sure, so this total percent equals I, the question is, what exactly does this mean? This is exactly the same as total equals total percent I. So anytime you see an operator to the left of the equal sign, we would say that this expands, or this is syntactic sugar for this line down here. That you take the equal sign, put the equal sign right here, take whatever happens to be to the left, put it right over here. The most common one of these that you'll see is plus equals, and then over here, plus equals like this. But this is a very common pattern, so you should get familiar with it. Just it should be like internal to you, obvious. 100%. You see this, you just think this. That it appears that often. Yes.
So does that mean for the last example, we can use minus?
Exactly. So for the previous two examples, so for this one right here, I could have said total equals total, or I could have said total minus equals 1 right here instead of total equals total minus 1. And up here, this could be total plus equals I. Yep, good question. Annika? So, yes.
No, so for, 7, is it total 2 because 2 is not in the range? And you go back up to start.
So here the total is equal, let's come back over to Python Tutor. Anytime we have a question about exactly what's going on in our code, we stick it into Python Tutor and run it, and we get to the line in question. So here, total starts at 42, and then on line 3, this is the only spot where total can change. The only time a variable can change is when it is to the left of an equal sign, so on line 1 and line 3. Here, total here doesn't really care about the range up here, except for what the I value is, what the current I value is. And so we do, this is basically saying like total equals total percent 10. So do the percent 10, 42% 10 equals 2, and that's why we get 2 right here. Was that answering your question or
Yeah,
something
so,
different?
Like, because it's like the range goes like 10, 12, 14, so then you get from just 10 to 2, but then when you went back up to 4, the 4 line, it wouldn't like, 2 is not in that range, so that's just end up total. So you would go to like 14, 14.
So you always go through every number in the range in a for loop. So if I press next again, then you see we'll go back up to the for loop and press next again, and we still go inside of here now with I equals 11. But when we execute line 3 next time, we'll do 2% 11, and 2% 11 is just equal to 2. So that's why it stays as 2. And we'll go, I'll keep pressing the next button here in a second, and you'll see that this I value will change for all the numbers between 10 and 15. Keep pressing next. So we'll keep trying all of these different I values until we get out of the range, and then we come down here. So yeah, the fact that 2 is not in this range up here is sort of irrelevant to why it's not going. Did that answer the question? Okay, Eddie?
Yeah, question for number 6. So for this one, we don't have an I in the for loop or for statement. So the range find means just we're gonna do it 5 times.
So the question, two-part question. The first part of the question is in the body right here. Eddie was observing that we didn't actually use this I variable anywhere. We have a total minus 1 over here, and it's not like total minus I. It's perfectly okay for you not to use a variable after you've created it. And this is one of the, I'm glad you brought this up, because this is one of the ways that it's easy thing to overlook and make a mistake. This 1 and this I look very similar to each other, and so if you're just reading it too quickly, you might think this is total minus I, but pay attention that it is total minus 1. So we don't actually have to use this I variable right here. The other part of the question is, how does this affect exactly what this range is over here? The fact that we're not using the I? And the answer is that inside of the body of a for loop, nothing can ever affect what the values of our range are. You can look at the range up here, use the cheat sheet to figure out exactly what the numbers correspond to it, and then you know that I is going to take on exactly those values, and there's nothing anybody can do to stop it. Did that answer your questions?
Not exactly. Yeah, so there's no I in it, like that I configure, but are we going to do the total minus 1 for the loop? Or we're just gonna skip that step because we don't have I?
So even if something does not have I, you still execute the step. Anything that's indented, you're going to execute.
So for this case, we're gonna do it 5 times.
And because the range up here contains 5 elements inside it, 0, 1, 2, 3, 4. It contains 5 things. We're guaranteed to do this body 5 times. Doesn't matter what's inside of here. We're guaranteed to do it 5 times. And so again, that's sort of one of the differences between the for loop and the while loop. The for loop, all you have to do is look at this range and you know exactly how many times it's going to execute. The while loop, you have to actually execute it in order to know how many times it's going to execute. And so that's why people prefer for loops over while loops.
The for statement is always followed by in range, right? Or
So for now, the for statement is always going to have in range. We'll see more complicated things in the future, but for now, it's always for some variable in range. Yes? Uh-huh.
What do like those 3 numbers mean, and like why did it only go?
Sure. So the place to be looking for information about range is on the cheat sheet in this box on the second page on the right, labeled integer sequences right here. This is where it describes what the range function does. And here are some examples. So if you have just one number, it goes from 0 up to not including that number. If whatever the n number is, we never include that n number for any reason. When you have 2 numbers, the first one's the start, the second one's the end, so 3, 4, 5, 6, 7. Always include the first number, never include the last number. When there's 3 numbers, it's like this one's called the step, you add this number each time. So instead of 2 to 3 to 4 to 5, instead of adding 1 each time, we're adding 3 each time. One of the general principles of this range function, I'll come over here to, just so I can type real quick, but if we do something like range of 5, that's the same as saying range of 0, 5. If you ever have something with just 1, it's just like having a 0 as the first parameter like this. And that's the same as range of 0, 5, 1. So personally, what I do is I just remember that like sort of the first value, the default value is 0, and the last value is the default value of 1. And then remember this, this form of it right here. And that way you don't have to really remember 3 separate things. You just remember this one thing, but that default value of 0, default value of 1, if nothing else is provided. There's a few more problems on the quiz, but they're all essentially the same. There's no new techniques or anything. They're all the same as what we've seen before, just slightly more complicated. And so if you're not understanding what's going on in any of them, then again, go to Python Tutor and walk through step by step. What I want to do next, though, is I want to talk about the lab for this week that you'll be doing on Friday and exactly what that will look like. So I'll switch over here to VS Code, and there's a file lab.py that has been uploaded to GitHub. And this lab.py file contains your actual lab, and all the labs from here on out will be of this format. There's just a lab.py file that contains the instructions for what you're supposed to do. And in this file, I'm gonna scroll down for a little bit. You'll see that there are a lot of functions that are defined in this file. So remember, anytime we have def keyword, that stands for define, and that's creating a function. This is the name of the function right here, and these are the parameters to the function. And the triple quotes is how you can make a large comment inside of Python. And when you have triple quotes at the top of a function like this, this is called a docstring. So this right here is called a docstring. This comment is called a docstring. And these two things, anytime you see these triple arrows like this is called a doc test. So triple arrow indicates a doc test. And a doc test is shows what the expected output of this function should be. So if we pass in the values of A and B, like 3.0 and 4.0, then right here it shows us what the expected value is. The expected value is 5. If we pass in 12 and 5, then the expected value is 13. And what we're going to do, these are the test cases for your code. In the lab, you're going to be implementing all of these functions, and the goal is to make all of these test cases pass. So you're going to write code right here for the hypotenuse function that's going to make it return the number 5 or the number 13 if these inputs are provided. I'm going to just real quickly show how to do that with this is-even function down here. Instead of implementing is-even, today in class, we're going to implement is-odd. So, oh, no, what you're going to do is even, since that's what I put here. On your lab, you have the is-even function and also an is-odd function. So we'll do this one, but then the is-odd is going to be extremely similar. So here, I'm going to comment out all of this stuff up here so that it doesn't get in the way. Save that. Come down here. Here's our is-even function down here. And I'm going to go ahead and press the triangle button right here. And you see that there's no output of this code. Even though I'm defining a function right here, I'm not using the print statement anywhere. I'm not using this function, so that's why there's no output. But what I need to do is I need to make this function return either true or false, depending on what is passed inside of it here. And a number is even if we take the number in, so in is our parameter being passed in, and we divide by 2, and the remainder is equal to 0, then the number is even. So we can just do return true like that. Otherwise, if it was not equal to 0, then it must be equal to 1, and so we can return false like that. And now I press the triangle button up here again, and you see that I still don't have any output down here. I still don't have any output. One thing that I can do to test this function is I could do something like print is even 5. And what should I get? I should get false, because 5 is not even. And if I do is even 4, I should get true, because true is even. So this is one way to go about testing your code, is to put print statements down here, calling the code and passing in numbers. But I am lazy. I hate doing this. I hate typing out all these test cases manually. I already have some good test cases up here, and I want Python to run them for me automatically. And that is at the very top of the lab file. Very top up here, there's this command right here, which tells Python how to test everything for you automatically. I'm going to go ahead and come down here and rewrite this command. Whenever you see Python 3 inside of a command, first of all, whenever you see a $, the $sign means that it's something that gets typed into the terminal down here. Whenever you see Python 3, what you want to do is put whatever, when you run the triangle button, the very first thing that comes in your terminal is the Python 3 command that you should use. For most people, you will just be able to type Python 3 by itself, like this, and that's all you have to do. Depending on your computer setup, though, you might have to copy and paste this right here and paste it down here.
Can you repeat what that does?
Well, we haven't talked about what it does yet. So far, we've just said that if you see a $, you're putting something into this terminal. If you see Python 3, you're copying and pasting whatever output is from the triangle button. Then you do -m doctest -- verbose like this, copy and paste it down here, and then the name of the file that you want to run. It would be lab.py for actually running the lab, but I'm going to run our notes. So notes _ Wednesday section 1 like this, and hit enter. And it's going to run all of those doc tests for me and put the output right here saying what passes and what doesn't pass. It says 5 tests passed because everything worked correctly. We'll have all lab on Friday to go over that in more detail. Again, it's going to be a little bit different for everybody's computer, but essentially the lab, we're writing code. The quiz will be sort of reading the code. If you have any more questions about anything, I'll happy to answer them right now. And I have my office hours right now, but otherwise, that's it for today. And I'll see you all on Friday.
Which one's Sunday, right?
So in my notes file, I was not getting
Yeah, Wednesday.
Wednesday.
Mine?
No, Monday.
It has to end in .py.
Oh, okay.
For it, so I know that it's a Python file.
Like-
When's the quiz on Monday, Wednesday, or Friday?
Quizzes are always going to be
Hello?
on Monday. Every Monday from now on, you'll have a quiz.
Hello, Mike.
About number 7 on the practice test. So is running the last position negative 4,
My
it
lap
gave
probably
result
scared.
negative 1. Then when it goes back up, it changed the result to 1. And that result gave us the final.
The previous, so whenever the red arrow is like this, it means this is what we're going to run next, but we haven't run it yet. So here it's going to do result times equals -1 as the next thing it does, but it hasn't done that yet.
Okay. Oh, so it's taking the previous result of -1 and then times it by -1. So when it does, oh, okay. Thank you.
Mike, I have a question.
I haven't technically submitted the first class, the very first one, which was the no delay. However, I already graded it.
I think it gave you full credit for it.
Yes. Should I still send it to somewhere or like this is just fine? I mean, it was all the same and it's on the website.
Exactly. So that's why everybody submitted the homework, just got full credit.
Thank you.
So, Professor, here we go.